Lesson 4, modeling data using exponential functions. So our goal is to represent data using an exponential function and interpret the graph to solve a problem. So in real life, they don't just give us the exponential equation. We have to determine what it is based on the data that we find. So this example here, Sarah did not feel well, so she visited her family doctor. The doctor thought she might have strep throat and sent a bacterial culture from Sarah's throat to the laboratory to confirm her suspicions. A lab technician recorded the growth of the bacterial population in the culture at a fixed time interval. The first 5 observations are given on the table below. Determine the exponential regression model for this data. Okay, so in questions like these, you always have to determine what is your x value and what is your y value. So we're going to say observations. These guys are our x values. And anytime we're talking about the number of bacteria, anytime we mention the number of bacteria, these are going to be our y values. All right, so how can we use our calculator to find our exponential regression or the equation? All right, so now we're going to have to turn our stat plot on. So we've been turning it off every time we are doing a graph. Now we're going to turn it back on. So we're going to go second y equals. We're going to hit enter. My cursor is blinking on, so I'm going to hit enter again. And that's all you have to do. And we're going to go back into y equals. You're going to clear out anything here. And now we're going to select values for our window. So we always want to make our window beforehand so that we can be sure to see our scatter plot once we have it all entered. So we're going to go into window. And our table is going to help us determine what our window is. So we just always want to go a little bit bigger and a little bit smaller than our values. So for example, my x min, well, I'm going to make that 0 because it's smaller than 1. My x max, well, I'm going to make it 6 because it's bigger than 5. So my x min, I'm going to make 0. My x max, I'm going to make 6. And my scale, well, it's perfectly fine if I count up by ones. All right, and then we're going to go back to our table. I want to be a little bit smaller than this. So let's say a nice round number, y min, we're going to put 6,000. Y max, well, let's go to 32,000. Obviously, counting up by ones is no longer reasonable, so we're going to count up by 1,000. All right, so now that we have our window already, we're going to go into our stat and we're going to enter our data into our calculator. So we're going to go stat. I want to edit a list, so I'm going to go enter. If you have something in your list, so say there's some numbers here, you're going to scroll up till the L1 is highlighted. You're going to hit clear, and then you're going to hit enter, and it's going to delete everything out for us. So we're just entering in our data values, not our windows, just our data values. So 1, 2, 3, 4, 5. Then we're going to scroll over. 6180, 9270, 13905, 20857, 31285. Always take a second to double check to make sure you have all your numbers entered correctly. Once you do, we're just going to hit graph, and there we go. There's our scatter plot. So our goal now is to find what we call the line of best fit. Or sorry, actually the curve of best fit in this case. It'd be a line of best fit if it was a linear regression. So the curve of best fit is basically the curve that plays connect the dots. It's going to be our exponential function. So to do that, we're going to go back into stat. And now I want to calculate something. So I'm going to scroll over. Specifically, we're going to go down. I want to calculate an exponential regression. So I have it highlighted so I can either hit enter or I can hit 0. We're going to double check. X list, yep, put that in list 1. Y list, yep, put that in list 2. Frequency list, we can always ignore. So we want to store our equation in our y equals so that we don't have to retype it later. In order to do this, we want to store a variable. So we're going to hit vars. Specifically, we want to store a y variable. We want to store a function. And we want to store that function into y1. So once we have all that there, we're going to go down and we are going to calculate. So we can write down the exponential regression. If you ever forget the form, it's written right here at the top of your calculator. So we would say this is y equals, our a value is 4120. Let's round to the nearest hundredth, so 2 decimal places. Our b value is 1.50 to the power of x. So you always have to have the correct format, meaning you have to have the y equals and the x. And you'll also get marked on correct rounding. So if the question said to the nearest hundredth, you would have to make sure to round your values properly. If it doesn't state, then you just have to make sure whatever you round to, you're rounding to properly. All right, so now I want to see this curve of best fit on my scatter plot. And in order to do that, we're just going to hit graph. And there we have it. So there's our exponential regression and our scatter plot. With any question to do with regressions, there's always 2 types of questions they can ask you. One, where they give you an x value and want you to find a y value. And one where you find a y value, or you're given a y value and you need to find the corresponding x value. So remember, x is our observation, y is our bacteria. So I'm just going to jot that down over here. X equals observations, y equals bacteria. Really, that is the hardest part of any of these, is determining if they're giving you an x or a y. So they want to use your exponential regression to estimate the number of bacteria. Okay, I know that's y. After the 10th observation. So 10th observation. So it's telling me as soon as I see observation, I'm thinking x. So it's telling me x equals 10. So this question is asking me, what is the y value I get when x is 10? So we can find that graphically. Obviously the problem, if I look into my window right now, my x only goes up to 6, but I want to find a 10. So I need to change my window to be allowed to see where x is 10. So let's put, say, 11 in here. First thing you're always going to show in your work is you're going to write down your windows. So 0, 11, 1. And y, we're going to say, well, we didn't change that any, so it's going to be 6,000, 32,000, and 1,000. All right. Once we have our window changed to accept our new value, we're going to go back to our graph. So because they're giving us an x value, we're going to calculate something. So we're going to go second, calc, and we're going to calculate a specific value. So we're going to hit enter, and you can tell you're in the right spot because your calculator is now asking you x equals what? It's telling you to put in a value for x. Specifically, we're going to put in 10. So again, we need to tell the marker on our diploma what we did, because we can't hand our calculator to them. So we're going to say that I went to second trace value, and I put x equals 10. And when we put in x equals 10, it told me that y equals 237,559.65. So this would give you part marks. Full marks, you got to write the final sentence. So we'd say the number of bacteria present on the 10th observation is, and I'm going to round to the nearest whole number, so 237,560. So that's what would give you full marks. So this is an example of they give you an x. So given x, and you are finding y. Which means this one we're going to be backwards. These are going to be my steps if I am given y, and we're going to be finding now an x. All right, so use your exponential regression model to estimate the observation. So observation is x, where there are approximately 46,927 bacteria. And we know bacteria is y. So I know in this case, y equals 46,927. Okay, so again, before you start any question, you want to check your window. So we're going to pop into the window. It's telling me I want my y to be 46,000. My y only goes up to 32,000, so we need to change that. So let's, again, nice round number, put 50,000. Okay, so first thing we jot down for our work is our window. So 0, 11, 1, and our y value is now 6,000, 50,000, and 1,000. All right. So now they're giving us a y. Sadly, in our calc, nothing here can I enter a y and it pops out the x. So when I'm given a y, we're going to go into the y equals. So we already have our exponential function into y1. So we're going to again jot that down on our paper. We're going to say y1 equals, and we're going to jot down our exponential regression. You can say 0, 7, 5, ... b is 1.499 ... to the power of x. And now in y2, we're going to put our new y value, 46,927. So 46927. Oops, not there. Come on, let me fix that. Make sure you're down into y2. So 4120 point. Okay. So yes, make sure you're down into y2. We're going to put 46927. See, this is why we jot things down on our paper in case we make mistakes. All right, so we're going to graph this, and we can see now we have two graphs. So for our work, we're just going to kind of do a quick little sketchy. So we're going to say, my graph goes like this. I have my other graph like this, and I'm looking for this intersection point. So I'm looking for the intersection. So now we can go into trace. We're going to find that intersection, and we're going to enter, enter, enter. Of course, we already know what y is, so our answer is x. So we're going to say x equals 6. Again, this is only part marks. You would have to say the 6th observation will have 46,927 bacteria. And there you have it. Those are the only two types of questions they can ask you for any regression. They give you an x and you're finding a y, or they give you a y and you're finding an x. All right. So here's your turn. I'm going to give you a hint before you start. These values you're going to put in for L1. These values you're going to put in for L2. And you're going to basically ignore these ones. All right, so pause the video, try this out, come back and see how you did. All right, so stat edit, let's clear out our lists. Okay, so 1871, 1881, 1891, 1901, 1911, 1921, 1931. Your diploma only usually gives you like 5 or 6 numbers. 1961 and 1971. On this side, 2.44, 74, 5.42, 7.22, 8.8, 10.38, 11.54. All right, so we have all our values entered. I'm going to go into my window. Remember, window, we always want to kind of go one step smaller. So let's do 1861. One step bigger, let's do 1981. And it seems to be that we're going up by 10 each time. My Y-min, well, let's go 0. Y-max, if I'm 22 here, let's just say 25. And for the fun of it, let's count up by 2s. And graph. There we go. We got our scatter plot here. So now we're going to run our regression. And you can see here they wanted us to the nearest hundredth. So I'm going to go into stat, calc, exponential regression. Remember, we want to store it. Vars over enter, enter. And we're going to calculate. Be very careful with this E. So this E in calculator talk means times 10. So our regression model for this one would be Y equals nearest hundredth 9.00 times 10 to the negative 18. So this part here is the E in calculator. You can't write the E for your work. You have to write times 10. And then our B value is 1.02 to the power of X. All right. So assuming the population growth continues at the same rate, estimate the population. Well, if I look up here, populations are my Y value, years are my X value. So I'm looking for Y when X equals 2020. Again, we're going to pop into my window, see that my X only goes to 1981, so I need to make my X bigger. So let's say 2030. First thing we jot down is our window settings. So 1861 to 2030, counting up by tens. Y's, we were 0, 25, counting up by twos. Your windows might be different. As long as you can see the graph, it's fine. All right, so you can see this is not a perfect correlation, meaning all of our dots are not exactly on our curve of best fit. That's why it's called a curve of best fit, not a curve that's going to be absolutely perfect. All right, they gave me an x value, so we're going to go into calc. We're going to do a value. My value is 2020. Hit enter, and there we have it. So y is going to equal 65.72. So in 2020, the population will be approx 65.72 billion. Don't forget that sentence. All right, hopefully that went well. Let's go on to the next example. All right. The intensity of light below the surface of a particular lake is reduced by 4% for every meter below the surface. The table below gives the intensity of light at various depths. I see a table, so let's go into my window. All right, it looks like we start at 0, so I'm going to go a little bit smaller. Let's put in -1. I end at 24. Let's go a little bit bigger. Let's say 30. And they look to be counting up by twos. My y min, it looks like I'm counting down. Let's say I go down to 0. I started at 100. Let's go a little bit bigger at 110. And let's say I count down by tens. All right. Now that I have a window, I'm going to go to stat. I'm going to edit my lists. So I'm going to clear out last question. Okay, so we have 0, 2, 4, 8, 12, 16, 20, 24. Over on the other side. And 2.16, 84.93, 72.14, 61.27, 52.04, 44.20, and 37.54. Take a second and double check. Columns line up. Are my numbers right? Yeah, that looks good. It wants me to do an exponential regression. Of course, at the moment, that's the only one we know. So we're going to go back into stat, calculate an exponential regression. We're going to store it into our variable function y equals and calculate. So this one doesn't give us a specific value to round to. Well, a looks like it's going to be about 100 when it rounds. So let's say y equals 100, 0.94 to the power of x. All right. So whenever we're talking about depth in this question, we're talking about x. And when we see percent, we're talking about y. So what percent, as soon as I see that, I know I'm talking about a y, of the original intensity of light remains at 10 meters. There's a depth. So I know that x equals 10 in this case, below the surface. So I'm looking for a y. And they gave me an x. So I'm going to go into my graph. I'm going to go second calc. They gave me an x value. Specifically, my x value is 10. All right. So I figured out that y equals 66.48%. So I forgot to jot down my windows, so I'm going to go back in there. -1, 32, and my y is 0, 1, 10, and 10. All right, got my windows, got my value. Now I need my sentence. The percent of original intensity 10 meters will be 66.48%. All right. Next question asks how far below. This is talking about a depth. I know this is x. The surface must the light travel before the intensity is 30%. I see a percent. I know this is my y value. All right. I look, 30% is going to fall within the window I have, so we're going to jot down the window. All right. In y1, we're going to have our regression. And in y2, we're going to put our new value of y. So I have my regression. I want my new value of y. Okay, we're going to graph that. I can see my intersection. So again, you're just going to kind of sketch a quick little diagram. Say I'm looking for the intersection. Okay, so we're going to go second trace, intersection, enter, enter, enter. So of course we know y is 30, x is going to be 29.5. So we're going to say at 29.5 meters, the light intensity is 30% of that at the surface. All right, here's another your turn. So pause the video and come back and see how you did. All right, this one just wants the regression. So we're going to go into stat, edit, clear our data. For my list 1, 0, 5, 10, 20, 30. We have 90, 78, 68, 52, 38, 26. Oh, something went wrong. My numbers don't line up. I forgot the 45 on this side. All right, so because it just wants the regression to the nearest hundredth, I can go right back into stat, calc, exponential regression. It doesn't want me to graph or do anything with the graph, so we don't have to store it. We're just going to go right to calculate. So our format, y equals 89.73, 0.97 to the power of x. And there you have it. That's your regression. All right. So for your information, right now we just know exponential regression. 90% of the time they're going to tell you what regression to use. In real life, we don't always know. So we have something called the coefficient of determination, this r² value. And basically all you have to know about this value is the closer r² is to 1, the better your regression is modeling the data you have. The closer it is to 0, the worse it is. So that would be like if I was trying to model a quadratic function that had increases and decreases with a linear regression. Obviously, that data is not going to work very well together. All right, so scatter plots are going to be made in our graphing calculator. If it's a growth model, we know that A is bigger than 0 and B is bigger than 1. If it's a decay model, we know that A is still bigger than 0, but B is a proper fraction or a decimal starting with 0 point. This is our function for our exponential model. And an exponential curve of best fit can be used to predict the values that are not recorded or plotted within our original data. We do call these predictions or estimates or approximations because it's a curve of best fit, not a curve of absolutely perfect. So they're only estimates. There you go. Try some homework and see how it goes.